Okay, good evening once more. My name is Tutor Poul. I'm from IQ Academy, okay? And we offer tuitions for first years that are doing natural sciences, or you're doing your pre-meds, okay? The courses meaning physics, biology, math, and chemistry, okay? And today we want to talk about the units and the measurements in chemistry. Specifically, we want to talk about significant figures and what we call as the scientific notation. Okay, so you are free. Okay, if I explain anything and you do not understand, okay, please feel free to just unmute yourself and then you can ask your question so that I explain it to you. Okay, so that you can actually learn. Okay. Okay, so in today's lesson, we want to focus on these few objectives here that I've outlined. We want to define what a measurement is in chemistry, okay? And then we want to look at the base units and the derived units, okay? From there, we'll talk about what we call as significant figures. I'm sure you are familiar with that term. You had physics, I don't know if it's on Tuesday, I think you also talked about significant figures. And then we move to scientific notation, okay? Again, this is familiar from your high school or secondary school. Okay, so these are objectives for tonight or in this lesson. Okay, so the first thing there is we want to define what a measurement is in chemistry. Okay, so a measurement is simply a quantitative observation, okay? A measurement is simply a quantitative observation, okay, which has mainly two parts, okay? So for something to be called a measurement, then these two parts should exist in that expression, okay? So the first part is that that measurement should have a number or a numerical value that tells us the size or the comparison, okay? And then the second thing that that measurement should have is a unit, okay? And we know that a unit will tell us the scale. For example, if I say I have this measurement as 1 kg, okay? So this 1 kg will simply mean that this one is telling us how much of this scale we have, okay? So we have 1 kg, which meaning the kg there is representing mass, okay? So the scale is telling us, the one is telling us something about the mass, okay? So measurement is a quantitative observation that should have two parts. Number one, should have a number or a value, okay? And then number two, it should have a unit or a scale, okay? If both those parts exist in a measurement, then we can say that that measurement is meaningful, okay? Meaning it can be interpreted, okay? So 1 kg, it means you're telling us something about the mass. Or if I say 5 meters, okay, I'm telling you something about the distance, okay? So numerical quantity and the unit, okay? And then we can define now what a unit is, okay? A unit of these same measurements that we are from defining, okay? So a unit is just simply a standardized quantity that is used to express a physical quantity, okay? So that physical quantity can be length, it can be time, or it can be weight, or any other physical quantity, okay? So that unit will be used to standardize, okay, that quantity. For example, when I say 5 meters, you will know that I'm talking about what? Length. When I say 10 minutes, you will know that I'm talking about what? Time. Or if I say 4 kgs, okay, it will mean that you know that I'm talking about weight or mass, okay? So a unit is just that thing that is used to do what? To standardize, okay? Standardize here. So this concept here, very important. Okay, I don't know, someone has their mic and mute. I'm getting some backgrounds. Okay, let me try to mute everyone. Okay, better. Okay, and then we have two types of units in chemistry or in any physical science. Okay, we have two types of units. One, okay, we have what we call as the base units. Okay, in some literatures, they refer to them as the SI units. Okay, so these are the first ones here, the SI units. And then from these SI units, we can have what we call as the derived units. Okay, so all these SI units, okay, when you combine them, you combine two of them, you can come up with what we call as a derived unit. Okay. Moving forward, okay. So this is a table here that shows us the SI base units. Okay. So in number, there are 7, and you're supposed to know them by heart. Okay, you're supposed to know all of them. You're supposed to know the symbol that they are represented by. So this is the symbol. You're supposed to know the name of that unit, okay? And then you're supposed to know the symbol again. Okay, so this is a typical symbol. And then here, you're supposed to know the symbol of this unit that you have here. Okay, so we have 7 base units. The first one there being time, okay? And we see that time is actually represented by a T, okay? A small letter T. And then the name of the units of the time, okay? The SI units for time are what we call as seconds. And these seconds, they are represented by an S like that. Okay, and then we have length as our second SI unit, okay? So this length can be represented by quite a lot of letters, right? We can represent it by L, some represented by X, some by R, some by S, okay? Yeah, so what do we use to measure length? Okay, we use a meter, and then the meter is represented by that M there, the symbol there, the small letter M, okay? And then we have all these others here. We have the mass, that is represented by an M, and then the base units for this mass are what we call as kilograms, okay? Or famously known as kg, okay? And then we have electric current, which is measured in amperes, and these amperes, their symbol is just a capital letter A. And then we have thermodynamic temperature, okay? So thermodynamic temperature is measured in kelvins. And so that's the standard unit for temperature, kelvins, when you come to physics and chemistry. Okay? But in these hospitals, we are used of those degrees Celsius, okay? But the standard unit for temperature, always remember that it is a what? A Kelvin, and it's represented by a calculator. And then we have the amount of substance, okay? So the unit that is used to measure the amount of substance is what we call as the mole, and this is the symbol. And then the last one there, the number 7, is what we call as luminous intensity. Okay? So the amount of light that is present, this is what it means here. So it is measured in units known as the candela. I know these are not that much common, okay? And I don't think in your pre-med you use this unless you specialize or you want to venture into physics, okay? Then you find these candelas. Okay, and then its symbol is just a CD there, okay? And then from these base units here, okay, from these base units here, the seconds, the meter, the kilogram, the ampere, okay, you come up with what we call as the derived units. So you can combine a meter and the seconds, you form another unit, okay? So for example, if I divide my meter, okay, I divide it with my second, I'll have meters per second. And we know that this meters per second is just the unit of what? Speed, okay? So all other units are derived from these 7 units here, okay? They are just 7, but the they will make a lot other units for other physical quantities. Okay, so from this, we come up with the derived units. Okay, so let's check on the next slide here. We have the derived units there. Okay, so if I multiply my length, okay, I multiply length multiplied by length, I'm going to have what we call as the area. Okay, and the area will have the unit meter squared. Okay, and then in the similar way, I can come up with all of these. Okay? And then in physics, you'll be actually asked to prove that this is the correct unit for density, this is the correct unit for what, okay? So you use the units for the base units for you to derive these units that you can see here. Okay, and then we move on, we can talk about significant figures, okay? So I have a question for you guys, okay? Anyone who can try and tell us what a significant figure is. What do you think a significant figure is? Anyone? Hello? Anyone? Okay, do you think a significant figure is? No one. Come on, guys. You wouldn't this on Tuesday in physics. I'm just repeating it in chemistry now. Okay. So what is a significant figure?
From what we learned the rest of it yesterday, we say the significant figures, these are important numbers.
Okay, yeah, okay. So from the name itself, you can tell that these are figures that are important, okay? Figures that are important, that is what we call as significant figures. So those important figures, if they are placed in, or they are shown in a measurement, okay, they will indicate the accuracy of that measurement, okay? So these significant figures actually are those numbers that will give us the correct information or the interpretation of a certain value. Okay, I think I have a definition. Okay, so this is definition here. We're saying significant actually means important, okay? And then the first significant figure or the significant digit of a number is the most important digit which expresses the size of the number, okay? And it is always non-zero, okay? If that number is in the first position, then it will be non-zero, okay? So meaning it can be a negative number, it can be a positive, but it does not have to be zero. So you can also define significant figures in this way, okay? We're saying significant figures are each of the digits in a number that are used to express it to the required degree of accuracy. Okay, so that is what we have there. And then it's very important that now to talk about the rules. Okay, how do you determine if you are given a number? How do you know that, okay, this number or this digit in this number is significant? Okay, so how are you going to determine that? So we now want to look at the rules. Okay. Okay, so we have, I think, 4 or 5 rules, okay, concerning these significant figures, okay. We have the first one, okay, that talks about non-zero digits, okay, meaning a number that is not zero, okay. So the definition says that all non-zero digits are actually significant, okay, because they will have a meaning. If I say I have 5 kwacha or $5, it gives you the information about the how much money I have, right? Okay, so non-zero digits, they're all significant. And then we have zeros now, okay? And these zeros are divided into 3 types. We have what we call as the leading zeros, okay? You can see them clearly here indicated. Leading, meaning they're in front, okay, before a non-zero digit. Okay, so you can see this 0.00 here. It's in front of this 5, okay? So they are leading, they are in front, okay? So we have leading zeros, and then we have zeros that are in between. These are also called as captive zeros, okay, because they are between non-zero digits, okay, like this zero here in yellow. It's between 5 and 8, okay, so it's captive. It's locked between those non-zero digits. Okay, and then we have what we call now as a trading zero, which means a zero that comes after the non-zero digit. Okay, so it's important to know the rule that contains this type of zeros, these and this, and then you'll be ready to go. So let's look at those rules now, one by one. Okay, so the first one we are saying non-zero numbers, okay, are always what? Significant. Okay, so non-zero numbers are always significant. And then here I have an example. If I say I have 312 centimeters, okay, we can see that there's no zero here. So how many significant figures will we have in this number? We'll just count 1, 2, 3, okay? And then we also have this measurement here, okay? So how many non-zero digits do we have here? We have 1, 2, 3. So both of these numbers, they have 3 significant figures, okay? Then the next one, we want to talk about the leading zeros, okay? So the leading zeros, the rule is that they are never significant if they are present in the number. They will never be significant, okay? The leading zeros are never significant. So if I'm given this measurement here that you can see, okay? You can see that I have a lot of zeros in front of this first non-zero digit, which is 4. So all these zeros here in front, they are not significant. Instead, they are there to just help us to know the position of the decimal place, okay, or the decimal point. Okay, but they will never be significant. So this number here, it has how many leading zeros? 1, 2, 3, 4, 5. And all these zeros are not significant. So if they ask you, how many significant figures does this number have? You just say 2, okay, because you can only see 4 and 7 there are the ones that are significant. Okay, and then we can talk about the captured zeros or the in-between zeros. Okay, so the in-between zeros, the rule is that they are always significant. Okay, if you have a zero between, if you have a zero or you have zeros between 2 non-zero numbers, then those zeros in between, they will be significant. Okay, so that's the rule. So if I have, for example, this number here, you can say I have 4 and then 005. So because these 2 zeros here are in between the 4 and the 5, okay, they will be considered as significant. And then it will be the same even for this measurement here. You can see I have 2 zeros in between the 4 and the 5, so they will be significant. So if we are to count the number of significant figures in this number and the number of significant in that number, we'll just say they are what? They are 4. Okay. And then we can talk about now the trading zeros. Okay. So the rule is that the trading zeros are a special case. Okay. They can be significant or they cannot be significant. Okay? So what makes them significant and what does not make them significant? Okay. So here I was saying the trading zeros are only significant, okay, if they are present with a decimal place. Okay, so if there's a decimal point somewhere and we have trading zeros, then we'll consider those trading zeros as significant. Okay, so here I have one number that is written in 2 different ways. So I have.
Hello. That's all right.
Someone has a question? Okay. Thought someone had a question. Okay, so I have 120 here, but I've written it in 2 different ways, right? So I have 120, I've just written it plainly like that, like 120 milliliters. And then here I have 120.0 milliliters, okay? So you can see that because this number here does not contain a decimal point, okay? It will have only 2 significant figures, which is the 1 and the 2. This 0 will not count it as significant because there's no decimal. And then if I come to this number, which is down here, you can see that I'm saying this number here has 4 significant figures. Why? Because there's a presence of this decimal point here, okay? So it means you actually count the zeros as significant, okay? So when there's a decimal point, we count them as significant. If there's no decimal point, we don't count them as significant, okay? So it's very, very important to know, okay, that rule. Okay, and then we can move. Okay, so after the trailing zeros, now we can talk about what we call as exact numbers, okay? We can talk about what we call as exact numbers. So the exact numbers, the way they are given, okay, they do not contain any significant figure, okay? They do not contain any significant figures. It's just an exact number, okay? So these are numbers that are actually obtained by counting, okay? Or they were set by the international board, okay? That, for example, 1 inch, okay? For example, 1 inch, no matter where you go, okay? If you go to Congo, if you go to America, if you are in Zambia, no matter where you are, 1 inch will always be equals to 2.54 centimeters, okay? So that's the conversion unit. So these two numbers here are exact numbers because 1 inch is exactly this number here, okay? So it means this one here has no significant figure because it's an exact number. And then even this 2.54 here will have no significant figure because it's an exact number, okay? For example, you want to go to school, right? You're preparing for the university, and then you buy 14 pencils, as I have put it here, okay? Those 14 pencils, okay, you got that 14 by counting, like you counted them 1, 2, until you have 14 pencils. So it means that 14 does not have any significant figure because it's a number that is obtained by counting, okay? So what we see from this is that for a number to have significant figures, then that number should be a measured value, right? Okay, so take note of that. For something to have significant figures, then it means that number, okay, should be a measured number, okay? If you obtain a number by counting, then it means it has not significant figures. It's just an exact number, okay? So in case you see a question, what is an exact number there? Just know that this is a number that you obtain by counting, okay? By counting and not measuring. Okay, so if you have any question, you are free to ask. Okay, just unmute yourself, and then you can actually ask me. Okay. Okay, and then these are the rules here. Now I've summarized them. Okay, so captured zeros are always significant. Non-zero numbers are always significant. Leading zeros are never significant. Trailing zeros are only significant if there's a presence of a decimal number there. Okay, and then for exact numbers, okay, which can be grouped into counted numbers like those 14 pencils, we do not have any significant figure, or numeric definitions like that one we had, like 1 inch is equals to 2.54 centimeters. It means in those numbers we do not have any significant figure. Okay, so take note of that. And then this is an example here that I put for you guys. So when I upload the notes on Drive, you can actually go through this and then you try to answer. But anyway, I answered for you. I was saying 46 marbles. So these 46 marbles, they were obtained by counting. So it means there will be no significant figures there because you obtain that number by counting. Okay. And then these others here you can determine, okay, based on the definition that we have learned. Okay, those rules there, you can use them to answer this. Okay, and then you can see here down, I have this number. I was saying 6.02 multiplied by 10 to the power 23 atoms. Okay, how many significant figures are there? None. Okay, why? Because this is a numeric definition. Okay, we are saying one more of anything contains this number of atoms. Okay, So there are no significant figures in this number. Okay, and then we move. This was me trying to illustrate what I was talking about. You can go through this. Okay, and then now we can talk about the rules for rounding off. Okay, we can talk about the rules for rounding off. Okay, so the first rule states that I'm sure we are all familiar with rounding off. Right? We've done it at primary and secondary school. Okay, so the rule one is that if the remainder beyond the last digit to be reported is less than 5, then it means we drop the numbers past the last digit, okay, without increasing the preceding number. Okay, so for example, if I have this number here, okay, and I want to round it off to the nearest 10th, okay, if I draw a line here, and then I check my number that is here, okay, so if my number, which is here, is less than 5, okay, for me to round off this number, okay, I'll just drop off these remaining numbers here. It will have no effect on this preceding value 3, okay? So if I round off here, it will just be 5.3, that's all, okay? But in a case where I have a number here that is equal to 5 or is more than 5, okay? It means I have to add 1 to the number that is in front of it, right? That is preceding it, okay? So in this example here, you can see, if I want to round off to the nearest 10th, if I draw a line here, okay, and then I check the number that is there. So if I check the number that is there, I see that is 9, and 9 is actually greater than 5, right? It's actually greater than 5. So it means when rounding off, I'll have to add 1 to the preceding number, which is 7, okay? So if I add 1 to the 7, you can see that I have 5.8 there, okay? So take note of that, okay? And then these rounding off rules here, we have a special case if the value that is here is the actual 5, okay? So let me talk about those special cases here, okay? So rounding off the rule, especially when you have the 5 digit there. So pay attention, right? So I'm sure you knew what I'm just from explaining here, but this one, I think we know it at the university level. Okay, so let me explain. So if the digit 5, okay, if the digit 5 is followed by non-zero numbers, okay, then the preceding number increases by 1, okay? So if, for example, in this one here, this 5 here, after the 5 here, we have after the 5 here, we have a 3 there, which is a non-zero number, right? Okay, so if this 5 is followed by a non-zero number, it means the preceding value there will increase by 1. Okay, so you can see that if we round off this number here, this will just become 4 because we have 5 here that has been followed by non-zero numbers. Okay, even here, we do the same because we have 0 quite all right here, but there's a 2 here. A 2 is a non-zero number. So this 5 is followed by non-zero numbers here, okay? It means if I round off from here like that, it means the 6 there should increase by 1. And then even here, we do the same. These 2 should increase by 1. And so it becomes the 3, okay? So this is the normal thing that you know, okay? But now there's a difference that comes about if I have this situation here, okay? So what does that situation say? It says if the digit 5 is followed by only zeros, or it's not followed by any number, okay? Then the preceding number will only increase by 1 if it is odd, okay? But if it is even, it means the number will remain unchanged. So that's where the difference is. So what do I mean by that, okay? So we have this 5, right? And then we want to round off here, okay? So we check this 5. Is it followed by any number here? Okay, we see that there's no number here, okay? There's no number here. And then we check the preceding number here. So the preceding number is an odd number because 3 is an odd number, right? Okay. So if this preceding number here is an odd number, it means that 3 will have to increase by 1. And so we have 7840 there. Okay. And then here, okay, is now the other situation that confuses students. Okay. So if I have a number, okay, and then 5 here is not followed by any number here, or if they were just zeros this side, okay, and then the preceding number there, I have a 6, and we know that 6 is an even number, right? Okay, it means when I round off this number, the 6 here, will not increase by 1. It will just remain the way it is like that. Okay, it will remain the way it is like that, and then here where we had 5 here, we can put a 0. Okay, so take note of that. If the number that is preceding 5, the 5 which is followed by only zeros or no number at all, it means this number here will not increase. It will just be the same like that. Okay, so you can see that these numbers remain the same. And then even this one down here, okay, even that one down there, we can see that if I want to round off here like that, okay, if I want to round off here like that, okay, we can see that this 5 is actually followed by a 0, okay? And then what number is preceding it is 7. Is 7 odd or even? Okay, so 7 is an odd number, right? Okay, it means the 7 should increase by 1. So you have this number there, okay? So the special case is this guy here. So if the 5 is not followed by any number, or it's only followed by zeros here, and then the preceding number is even, it means when you round off this 5, this 6 here will not increase by 1. It will just remain the same. Okay, so it's very important to take note of it. Okay, and then we move. These are examples here I was rounding off for you, so you can actually look at them. Okay, when I upload the notes, and then okay, my slides have stopped. Okay, and then let's now talk about the rules when you are adding or subtracting, okay, numbers that have different number of significant figures. Okay. Okay, so let's say, for example, we are adding this number here. Okay, we are adding this number to that number. Okay, or we are subtracting that number from that number. Okay, so the rule is the same whether you are subtracting or you are adding. So we can see that this number here has how many decimal places? It only has 1, 2, right? So it has 2 decimal places. And then the other number there, how many decimal places does it have? It has 1 decimal place. Okay, so the rule is when you're adding such numbers that have different number of significant figures, okay, because this one here has 5 significant figures. Let me write on top here. So 5 significant figures. And then this one here only has 2. Okay, so when you're adding or subtracting 2 numbers that have 2 different number of significant figures, then after you add, okay, your answer should contain the same number of decimal places as the least as the number that had the least number of decimal places. Okay, so this one had 2 decimal places here, and then this one had 1. So when we add this, we actually get this as your actual answer, right? Okay, but when representing it or giving it as your final answer, okay, you have to make sure that this number has 1 decimal place. Why? Because one of the numbers that we are adding had 1 decimal place there. Okay, so it means you have to round it off from here. Okay, you have to round it off at here, right? You round it off at here. So it means you look at this 4. This 4 is less than 5, right? It means this number here, the preceding number, will just remain the same. So you actually represent your final answer as just 334.5. So you remove the 4. Okay. So make sure that when you are adding or you are subtracting, the answer that you should get should have the least number of decimal places. Okay. Okay. So I hope that is clear. And then we can look at the rule that involves multiplying and dividing, okay? So addition and subtraction, they go together. Then multiplying and division, they also go together. So let's look at the rule for multiplication and division. Okay, so the rule for multiplication and division says that the answer will have the same number of significant figures, okay, as the number with the least number of significant figures in the calculation, okay? So take note that when you are adding or subtracting, you are looking at the number of decimal places, okay? But when you are multiplying and you are dividing, you are looking at the number of significant figures, okay? So take note of that difference. So for example, if I have 30, okay, if I have 30 here multiplied by 1.5, okay, we see that this number, the 30 here, only has one significant figure. And then the 5.1 has two, okay? So meaning when you multiply these two numbers here, you have to make sure that your answer will only have one significant figure, okay? Because this one here is less than 2, okay? So your answer should have the least significant figure in the calculation. So if I multiply 30 multiplied by 5.12, I get 153, okay? But 153, okay, when we count the number of significant figures here, we see that there are 3. Oh, okay? But you can't represent your number like that. It will be wrong. So it means we have to round off this number such that it only has what? One significant figure. Okay? So how are you going to do that? You're just going to round off here to the nearest hundreds. Okay? So you round off here. Then you check this number. Okay, so this number is followed by a 90. So it means the other one can increase by 1 here. Okay. Okay, so this, when you round off here, it means you add the 1 to this one. Okay, so it becomes 200. Okay, so according to the rules, or when you are solving questions in chemistry, okay, and you're asked to apply these significant figures rules, okay? So 30 multiplied by 5.1, the correct answer will just be 200 and not 153, because 153 will have 3 significant figures, but we want our answer to have the least number of what? Significant figures. So the number there will just be 200. I hope that is clear. Okay, and then we move. Okay, so this is an example here explaining the same thing that I was explaining. You can go through it when I upload the notes on Drive. And then, yeah, also this is an exercise, and I was even putting the solutions for you here. So you can easily actually read through this. And then now we can talk about scientific notation, okay? Scientific notation. This notation is very important, okay, to scientists or to students who are actually taking physics and chemistry, okay? Because it lessens the work, okay? And it makes your presentation to be more clear, okay, and easy and straightforward to follow. Okay, so this scientific notation is also called as exponential notation, okay? Why is it called an exponential notation? Because there's a presence of 10 to the power something. We know that if we have a number to the power something, that is an exponent, right? Okay, so scientific notation is also called exponential notation. And by definition, we are saying that, okay, scientific notation is just a method, okay, or a way of expressing a very large number or a very small number, okay, as a product of a decimal that is less than 10, okay, but greater than 1, and then multiplied by a power of 10. Okay, so these are examples. We have this number here, the 5 or the 1.5 here, okay. So this number here is what we are saying as representing numbers as a product of a decimal number that is less than 10. So 1.5 is less than 10. And then you are multiplying by 10 to the power something. Okay, this is what scientific notation is. Even this number here, you can see that it's scientific notation. And then we are multiplying by 10 to the power something. Okay, so it's very important to notice that this number here, it should be greater than 1. Okay, I repeat, should be greater than 1, but less than 10. So meaning if I have this number here, 0.91, okay, multiplied by 10, maybe to the power 7. Okay, so this number, they have written it here. It's not expressed in scientific notation. Why? Because this number here that I've put in front here is actually less than 1. Okay, so the number that should be here should always be greater than 1, but less than 10. Okay, meaning if so this is not scientific notation. Across it, meaning if I have another number where I have, for example, 20. Okay, 20 multiplied by 10 to the power 5. Okay, so this number here will not be in scientific notation. Why? Because this number here is greater than 10. Okay, so the number that should be here should be, this number will not be scientific notation because it's more than 10. Okay, so the number that should be here should be greater than 1, but less than what? 10. So you can say that that x value that you put there should always be less than 10, but actually greater than 1. Okay, so make sure you understand that. Okay, and then this notation actually is very helpful, or what I was explaining. Why? Because you can use it to express a very large number, okay, in a simple way. So for example, you can see this number that I've put there, right? Okay, I don't know, I even don't know how to read this number. I don't know if it's a million or a billion or a trillion. I don't know, I have no idea. So for example, you're given such a number, okay? You will see that it will be time wasting writing this number, okay? It will be time wasting writing this number. Write 2 and then start writing these zeros. By the time you are done, the time for finishing the exam was also finished, right? Okay, you're just on one question. So scientists thought it wise to introduce this scientific notation because we can actually use the scientific notation to express this number in a very simple way. Okay, so we just actually have to move the decimal place. Okay, so because this number here, it means the decimal point is at this place there. Okay, so we can move these decimal places and count how many times we shall move it. So 1, okay, 2, 3, 4, 5. We have 6 there, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. Okay? So we move this decimal place how many times? 30. Means so this number can just represent 2, 2. Okay, I can represent it as 2 multiplied by 10 to the power 30. Okay, so you can see that it's actually easier to write it in this form than that form that we have on top there, right? Okay, definitely. Okay, so I can just write 2 multiplied by 10 to the power 30. And I even forget than writing 20000 until I don't know. Okay, so it's a very important concept. Okay, we should actually enjoy it and embrace it. Okay, so that's what scientific notation is. Okay, so now you need to know how to use it. Okay, how to use it and what it means when you move the decimal place either to the right. Okay, so for example, if you move your decimal place to the left, like the way I did here, okay, it means the power that you're going to put here is going to be positive. Okay, so if you move your decimal place to the left like that. Okay, if I move my decimal place to the left like that, okay, it means the power that the 10 has to have there, it will be what? A positive number. Okay, so you can see there I'll put a positive 30. Okay, but let's say, for example, at this number 0.0002, okay? And then I want to express it in scientific notation. Remember, this number should be greater than 1, but less than 10. So if I move this point now, I'm moving it from the left, I'm going to the right. So I'm going 1, 2, 3, 4. Okay, so I've moved 4 times. So this number is the same as 2 multiplied by 10 to the power 4, okay? But this 4 is going to be negative. Why? Because I was moving in the right direction like that. Okay, so if you move in the right direction like that, it means your power will be what? Will be negative. Okay, so you can put a negative power there. Then if you move to the left, it means you have positive power, right? Okay, I hope that that is clear. I hope that is clear. So now we move, okay? Oh, I forgot to explain the representation there. Okay, yeah, so the scientific notation will always have the significant here number, okay, which should be greater than 1 but less than 10, and then multiplied by 10. So this 10 is what we call as the base, and then this n is what we call as the exponent, or we can call it power. Okay, so you see when you look at SAD in mathematics, okay, you also find the base and these exponents. Okay, so this is the representation, and then we can move. Okay, so here I was giving an example. If you move the decimal place to the left, okay, it means your power will be what? Positive. If you move your decimal place to the right, it means your power will be what? Negative. So take note of that. Left, positive. Right, negative. Okay, and then this was an example here again. And then you can actually be asked to do 2 things with this concept of significant figure, scientific notation, I mean, okay? So you can be given a very big number, and then they can ask you to represent it in scientific notation, or it can be the opposite. You can be given a number in scientific notation, and then they ask you to represent it as a large number or a small number. Okay, so you can see here I have this 52,314, and then they're asking me to change it into a scientific notation. So I know the decimal place is at the end, so I'll just move it 1, 2, 3, 4. Okay, so I've moved it 4 times. It's now there, you can see it. Okay, okay, and then which direction have I moved? I've moved to the left. So the power here that the pen will have actually positive power. Okay, and then the other thing I think I forgot to mention, when you are finding this scientific notation, make sure that the number of significant figures in the original number, the way they have given you, okay, even the number that you've expressed in scientific notation should have the same significant figures. Okay, so for example, this number here, it has how many significant figures? We see that it has 5 significant figures because all these are non-zero numbers. Okay, so make sure when you express it in scientific notation, even the answer that you're going to get should have 5 significant figures. So you can see here, after moving the decimal place, I can still count these as my 5 significant figures. Okay, so take note of that. Let me also give this an example here. Okay, so you can see that in this number, the decimal place is at the beginning there, the decimal point. So I can move this decimal place 1, 2, 3, 4, 5. Okay, so the decimal point now has come there. So this is 4.28 multiplied by 10 to the power 5, but that 5 will be negative. Why? Because I'm moving in the right direction like that. Okay, but now notice this. This number here, it had 4 leading zeros. And we said leading zeros are not what? Significant, right? Okay, so meaning this number only had how many significant figures? 1, 2, 3. And then notice that even the number in the scientific notation there still maintains the 3 significant figures, because I can also see 4, 2, and 8 there, which are just 3. Okay, so this is the scenario where they give you a number and then they ask you to turn it into scientific notation. And then it can be opposite here. They can actually give you the number and then they ask you, they can give you the scientific notation number and then they ask you to turn it into the actual number there. So for example, here they have given us, this is 7.74521 multiplied by 10 to the power 5. Okay, so this to the power 5, it means that from the original number, they just moved 5 steps to the left, right? Okay, so if you want to represent it in the original way, okay, it means we just have to move this decimal place 5 times in the opposite direction. Okay, so for them to have a positive power, it means they went to the left. They move the decimal place 5 times to the left. Okay, so as you have the original number, just moving this decimal place 5 times to the right. Okay, so you can see that from here, move it 1, 2, 3, 4, 5, and we have gotten this number here. So we have changed back in scientific notation. We have changed back to the actual number, right? And then we can also do the same for this number here. Okay, we can do the same for that number. Okay, and then here in the boxes, I was given the explanation. So in case you didn't actually get it, you can always refer to the drive for the notes and the recorded session. Okay, I think we are done. And then this is an example that I've put for you. You can try it out on your own. Okay, you express these numbers in scientific notations. Okay, so these are just numbers that I was coming up with, but they're actually, okay, so this is another example. They're actually exam sample questions that you need to familiarize yourself with. Okay, so the concept is very simple. Okay, just follow whatever I explained there, okay, and follow whatever is in the notes. Then you'll be good to go. Okay, so I've put a lot of exam questions here. So you can just try to practice. Okay, so start early practicing. Because when school opens, first week, second week, the pressure will build up. Okay, so don't relax. It's actually very, very, very difficult, okay, to do NS or pre-med courses. Okay, so you have to be smart, you have to work hard. Okay, so start studying right now. Okay, don't say, wait until I go to school. Okay, you will find yourself in pressure. So start studying at least. You know something in chemistry, in math, just like that. Okay, and then these are the exam sample questions here. I was getting them from past papers and tutorial sheets. Okay, so you can see how they ask. They have given us numbers here, and then they are saying determine how many significant numbers are in each of these numbers. Okay, so that's a question to you now. So let's go on the first one here. How many significant figures are in this number? And then you also explain to us why you are saying that. Anyone? How many significant figures are in this number?
There are 3 significant figures there.
Okay, why do you say there are 3 significant figures there?
Oh, because they are, what do you call them? There are 2 non-zero digit numbers, and the other 0 is between non-zero digit figures.
Okay, excellent. Okay, because we have a 0 in between 2 non-zero digits there, it means that what? It means that all the numbers there are actually significant. Okay, and then
Yes.
another person, how many significant figures do we have in this number here?
We have only one significant figure there.
Okay, why do you say so?
I say so because the two three zeros there. There's no the decimal place there. There's no decimal
Okay.
place there.
Yes. Okay. So these zeros are fading zeros. Okay, but they do not have a decimal point there. Okay, so that makes them non-significant. Okay, so they are actually only one significant figure here. Okay, so there are a lot of questions actually here. You can try all these. You can see here they're saying take these numbers out of the scientific notation and write them as standard numbers. Okay, so I explained how to do it. You can actually try these out. You can send me your solutions in the inbox and then I'll be able to guide. Okay, so I've put a lot of questions here. These are other questions there. These are still questions here. There are a lot of questions. Okay, so next time we meet, someone has a question? Okay, so next time we meet, we are going to look at the metric system and the unit conversions, okay? So that we can be able to answer questions such as this, okay? Convert centimeter to kilometer, meter to nanometer. We will look at this in the next session. Okay? So today I just wanted to do the significant figures and the scientific notation, okay? So you can try out what we've done here, like all these here we've done, okay? What is the rule when we are multiplying there? When we are multiplying numbers that have different significant figures, okay? We said your answer should have the least significant figure. And then when we are adding, we said your answer should have the least number of decimal places, okay? So take note of that. These are other questions. I've put in a lot of questions in here. Okay, so you should never fail a question about significant figures on scientific notation. Okay, you should never, because these are so basics. Okay, we have more hard things coming. These are basic things, so make sure you know them and know them well. Okay, because they will be the foundation for whatever you're going to do, especially in physics. Okay, if you don't know anything about the units, then you will be in trouble. Okay, even in chemistry, it's the same. So know them and know them well. These are all questions here. I'll actually create a day where I'll just be looking at how to solve these questions, okay? So that we can solve most of these questions. And then we'll see how it goes. Okay, we'll see how it goes. Okay, hey, seriously, my questions. Okay, so we are done. And then these are the services that we do offer as IQ Academy. Okay, so this is actually the last week that we are offering free classes for you guys to see how we do it. Okay, starting next week, only paid up members will actually be able to access our videos and our materials. Okay, so if you want to register, you're free to inbox me on that number. Otherwise, do you have any questions about what we've learned? Any questions? Anything that you were not clear about? I explained. Okay, no question. All right, so I'll actually end my class here. Thank you so much for attending and have a blessed night. We shall meet, shall continue the meetings even tomorrow, I think. Yeah.